Hi friends, welcome to Chitti Education Academy. Dear friends, today we will discuss thermodynamics most important questions. So let's start. The basic concepts and geometry of thermodynamics. So first question is, the energy of isolated system is always a constant which is given by. The answer is B. First law of thermodynamics. An isolated system is a thermodynamic system that cannot exchange either energy or mass outside the boundaries of the system. So the change of energy equal to 0 and change of mass equal to 0. So this is given by first law of thermodynamics. Next question. A series of operations which takes place in a certain order and restore the initial conditions at the end is known as a. Answer is C. Thermodynamic cycle. A series of operations which takes place in certain order and restore the initial conditions at the end is known as a thermodynamic cycle. And third question is, heat and work are the. Answer is path functions. So heat and work, these both are the path function. Let we see this one. What is the point function and path function? This is most important. So path function, magnitude depends on the path followed during the process as well as the end states. Okay. Next, point function, magnitude depends on the state only and not a how the system approaches the state. Okay, this is the difference between the path function and point function. And next question. So next question, fourth one. So what are the properties of the thermodynamic system whose value for the entire system is equal to the sum of their values for individual parts of the system? Is answer is extensive properties. So what is the extensive properties? So the extensive properties, sum of the individuals and sum of the individuals and entire mass, so both are equal. So for example, volume, if you want to break the volume in n number of and add the sum, and the sum is equal to the entire volume, so this type of property is known as a extensive property. And example of volume, enthalpy, entropy. Okay. Intensive property, an intensive property is a bulk property, means that it is a local physical property of the system that does not depend on the system size or the amount of matter, means mass. Amount of matter means mass of the system. So for example, pressure, temperature, refractive index, density and hardness of the object. Next question. Consider following properties. Okay. Temperature, viscosity, specific entropy, thermal conductivity. Okay. Which of the above properties of the system is or intensive? So we are already discussed about intensive. What is the intensive property? Independent of mass. So based on that, what are the these properties are independent or dependent on the mass? So let's see that. Answer is D. So all the properties are the intensive properties, means independent of properties. So for example, temperature, viscosity, specific, all the specific and properties. What is the specific entropy, specific volume, specific enthalpy and thermal conductivity? So these are all the intensive properties. Okay. Next, move to the next question. An open system. What is the open system? So the open system is a. Answer is A. A means a specified region where transfer of energy and or mass takes place. So both energy and mass are transferring. So this is a shortcut method to remember all this. So open system, closed system, isolated system. So open system, mass transfer, energy transfer. Closed system, mass not transfer and energy can transfer. Isolated system, both mass and energy not transferring. So this is the isolated system, open system. Okay. Move to the next questions. So let's arrange this one. So Closed system, open system, pump, turbine, nozzle. So arrange with this one. Increasing in static pressure, increasing kinetic energy, heat and work, mass and work interact, and heat and work interact, delivers the work. Okay, so this one. So let's find out answer. Closed system, only energy can transfer, no mass can transfer. Okay, so what is the answer? That one, heat and work. So first one D answer. First one D. Next one, open system. Open system means heat, mass, work are all the interact with the system. So answer is C. Next, pump. Pump is increase the static pressure. So that is A. Next one, turbine and nozzle. So increasing the kinetic energy. What is the increasing the kinetic energy means? Nozzle. Okay, and turbine. What is the turbine? And we have only one, deliver the work. Okay, so answer is A. So let's see. Closed system, heat and work are interact. Open system, heat, mass, work interact the system. Pump increase the static pressure. Turbine delivers the work. Nozzle increase the kinetic energy. Next, move to the next question. So the law which provides the basis of temperature measurement. What is the measurement? So what is the measurement of temperature? So which law is providing this one? GOVT law. Okay, GOVT law is providing the measurement of temperature. So what is this first law providing? First law is thermodynamics. First law of thermodynamics provides conservation of law of energy. Okay, conservation of law of energy. And second law of thermodynamics provides a basic concept of entropy. Okay, next, move to the next question. Which one of the following is a extensive property of the system? Extensive means sum of the individual equal to total volume. I mean total quantity. Okay, sum of the quantity is equal to total quantity. So enter this one: volume, temperature, pressure, density. What is the answer? Volume. Okay, next. Next, move to the next question. Pressure exerted by the gas in a closed container. So closed container, pressure exerted. So what is the answer? C. Strong function of density and temperature. Okay, strong function of density and temperature. Next question. Which of the following item is not a path function? We are already discussed work and heat and kinetic energy. These three are path functions. Okay, what is not a path function? Not a path function means is a thermal conductivity. So answer is thermal conductivity. Thermal conductivity is a not a path function. Next, move to the next question. Which one of the properties given below is an intensive property of the system? So intensive property means independent of mass. Independent of mass means volume, entropy, kinetic energy. These three are the extensive properties. Okay, and A. Answer is A. Composition. So volume, kinetic energy, entropy are the example of extensive property, whereas the composition is an example of intensive property. Next, move to the next question. Okay, heat, energy, entropy, Gibbs function. So match this one, list 2. So point function, path function, second law of thermodynamics, path function. So heat and work, we know that these are two are path functions. So here we have a heat is a path function. So heat is a path function. Next, next one, energy. Energy means let's see where it is. Okay, which pair of the following alternatives is a correctly matched? So let's find out which is correct one. Okay, path function is connected with point function. Actually heat is a path function. Okay, these are all the wrong. Next, energy is a path function. No, energy is not a path function. Next thing, entropy is second law of thermodynamics. Okay, entropy is the second law of thermodynamics. It is correct. Okay, Gibbs function is a path function. It is also wrong answer. Okay, correct answer is entropy is a second law of thermodynamics. Next, thermodynamic work is a product of. Okay, thermodynamic work is a product of. We know that work is equal to P into dV. dV means change in volume. So answer is an intensive property of the intensive property and change in the extensive property. Intensive property and change in the extensive property. P is the intensive property and extensive property is volume. Okay, next integral of PdV. Okay, next these questions are more important. So bimetallic strip made of two different material bend during the rise in temperature because of difference in coefficient of linear expansion. Okay, so bimetallic strips made of two different material bend during the rise of temperature because of difference in coefficient of linear expansion. And next we have one question. Okay, let's solve this question. Okay, the gauge pressure in a truck tire before after journey was recorded as a 200 kilopascal and 220 kilopascal respectively. So before and after journey. Next, at the location where atmospheric pressure and temperature was 100 kilopascal and 27 respectively, how much the rise in temperature of the tire air after trip. So after trip, how much temperature increases in the tire. So we have to find this one. Okay, let's find this data. So in that they are already given atmospheric pressure, so 100 kilopascal, atmospheric temperature 27 degrees centigrade. So convert into the kelvins, and pressure, okay, pressure of the gauge, okay, gauge pressure is 200 kilopascal and gauge pressure 2 is equal to 220 kilopascal. Absolute pressure is equal to 300 kilopascal, means absolute pressure is equal to gauge pressure plus atmospheric pressure. Okay na. So and absolute 2 1, so these also gauge pressure plus atmospheric pressure. So let's we find this one. So V1 equal to V2, so the enter volume is same, so initial and after the volume is same, so equal to, so P1 by P2 equal to T1 by T2. So this is the formula, P1 by P2 equal to T1 by T2. Okay, T2 equal to, we have to find the after journey of temperature in the tire. So T2 equal to T1 into P2 by P1. So let's calculate this one. We get 320 Kelvin or 47 degrees centigrade. Next, the condition for reversibility of a cycle is, so what is the condition for reversibility? So answer is, the pressure and temperature of the working substance must not differ appreciably from those of the surroundings at the stage in the process. All the process taking place in the cycle of the operation must be extremely slow. All the working parts of the engine must be friction free. So all above answer is correct. So if want to a process or a cycle reversible, so that reversible must be follow these conditions. Okay, next question. So next question is one of the important question. So which of the following is example of irreversible process? So irreversible process, what is the irreversible process? Unrestricted expansion of the gases. Okay, so this is the example of irreversible. So we have to see three basic concept. Okay, mechanical and friction, fluid friction, these are the causes, and unrestricted expansion of gases, heat transfer with a finite temperature difference. So these three conditions are main causes of the irreversibility. Okay, next thing, next question, 19th one. Okay, which of the following is considered as a thermodynamic potential? So thermodynamic potential is enthalpy. So enthalpy is considered as a thermodynamic potential. Next one, the ratio of absolute temperature T2 by T1 at two different state in adiabatic process. So answer is, so adiabatic process P2 by P1 power of gamma minus 1 by gamma. Okay, these are the adiabatic process. Okay, next thing, what is the one pressure of 1 atmosphere equal to? So what is the pressure of 1 atmosphere in the means? So 0.10325 megapascal. So these are the correct answer, and we can write it as a bars. So bars means into 10 to the power 5. So already it is a megapascal. So answer is 1. Okay, we can convert these atmosphere pressure in this type. Okay, 101.325 pascals, or we can, if you want to convert in the bars, into 10 points, 10 to the power minus 5. No, so next convert this point into 1.01352. Okay, next, or 760 mm of Hg, or 760 torr, or 0.1010325 megapascal, or 14.6959 pound force per square inch. So these are the measurement of atmosphere pressure. Okay, next another question. A steel ball of mass 1 kg and specific heat 0.4 kilojoules per kg Kelvin at the temperature of 60 degrees. Okay, this is the initial condition. It is dropped into 1 kg of water at 20 degrees centigrade. So what is the final steady state of temperature of water? Okay, now, so the ball temperature is more than the water, so the heat transfer from the ball to the water. Okay, this is the main condition. So how much water will absorbed, means how much temperature of water will increase. So let's we find this one. We know formula is equal to MCP, means mass of the ball and specific heat of the ball and temperature of the ball in, and what is the temperature of final one, equal to the mass of the water, specific heat of the water, and initial temperature we know, and final temperature 20. Okay, these are the, let's we find this one. So let's solve this one. We can find this, what is the final temperature of the water and how much of heat absorbed by the water. Okay, so it is at T 23.5 degrees centigrade. Let's find. Okay, so these are the electrical question, but we can solve it, and it is also one of the important, because in the thermodynamics somewhat electrical type of questions also come. So 120 volts of electrical resistance heater draws at 10 amps. It operates for 10 minutes in the rigid volume. Calculate the work done on the air in the volume. So let's we calculate. Work done is equal to voltage into current into time. Okay, voltage into current into time. So voltage is 120. How much current? Amps, 10 amps, and 10 minutes converted into seconds, 10 into 60. Okay, next 72 into 10 to the power 4 joule, or 720 kilojoules. So these are the answers. Move to the next question. So next one. The air is compressed in a cylinder such that the volume changes from 0.2 to 0.02 meter cube. The initial pressure is 200 kilopascal if the pressure is constant. Okay, initial pressure is 200 kilopascal and the pressure is constant. Approximate work done. So what is the work done? So we know the work done is equal to integral of PdV. So we know the two volumes and one pressure that is constant. Okay, so pressure is 200 and into volume is 0.02 minus 0.2 means final volume minus initial volume. So minus 36 kilojoules. So this is the approximate the work. Okay, next let's match this list 1 to list 2. Okay, next, so list 1 first, second, GOVT law and third law. Okay, absolute zero temperature, initial energy, temperature, entropy. So these are the left one and right side. Let's connect these two things. Okay, first law know that and first law, second law, GOVT and third law. So answer is, first law is internal energy, second law is entropy, third GOVT means temperature, and third law absolute zero temperature. So this is the matching. Next, which of the following process is irreversible process? What is that? So isothermal, adiabatic, throttling, all of the above. So throttling is a irreversible process. Okay, throttling is a irreversible process. Next, a cylinder contains 5 meter cube of ideal gas at a pressure of 1 bar. Okay, and this gas is compressed in a reversible isothermal process. Still, its pressure increased by 5 bar. Okay, let's this answer. We know initial volume and initial pressure, final pressure. So we know the basic formula of work done. So integral of VdP. So change in pressure we get na. So integral of VdP. VdP legs work done is equal to V1 V2 P2 by P1. We already know the P1 P2. Okay, let's submit this one into the formula. 100 into 5 into ln 50 by 100. So 804.7 kilojoules. Okay, next, these are the one of the important question. If H refers the T heat, T refers the temperature, then the throttling process. What is the throttling process? Throttling process, just we studied irreversible process, a throttling process. So the throttling process is a constant enthalpy. So initial enthalpy and final enthalpy also same. So H1 minus H1 equal to H2. So means B is the correct answer. Which of the following process are thermodynamically reversible? Thermodynamically reversible is isothermal and adiabatic. So throttling, free expansion, constant pressure and constant volume process all are the thermodynamically irreversible. Okay, and adiabatic process are thermodynamically reversible. Okay, these are the answer. Next, most efficient method of compressing air is the compress it isothermally because temperature constant. So temperature constant means we can get a good compressed air. Okay, so the work of compression of the steady flow work input is gas. So gamma minus 1 gamma by gamma minus 1 P1 V1 into P2 by P1 whole power gamma minus 1 by gamma entire minus 1. So for reversible adiabatic compression, okay, this is similar for the reversible polytropic compression. So okay friends, these are the most important questions in thermodynamics. Thank you friends watching for this video, and let's share this video to your friends, and don't forget to subscribe. And if you want to any other subjects and heat engines or thermodynamics as strength of materials, please tell me in comment section box. I will provide you. Thank you friends, thank you for watching.